Okay, so good morning, students. Uh, Today we will discuss about Cannizaros reaction. Okay, so first, what is a Cannizaros reactions? So here in this reaction, which compounds are participating? Cannizaros reaction. So which compounds are participating Cannizaros reaction? So generally, carbonyl compounds are participating Cannizaros reaction. Okay, so what are the carbonyl compounds? So carbonyl compounds, the compounds which contain C double bond O functional group, that is the carbonyl compounds. Okay, so here the carbonyl compounds without alpha hydrogen carbonyl compounds are participated. So without alpha hydrogen carbonyl compounds are, this is the formaldehyde. Okay, this is the formaldehyde. So here this is a acetaldehyde. Okay, acetaldehyde. So here this compound contains alpha carbon and alpha hydrogen. So what is the alpha carbon? So functional group adjacent to carbon is called alpha carbon. This is the functional group adjacent carbon is alpha carbon, so which contains alpha hydrogen. So that's why it is not participating in aldol condensation. So here this is the functional group, there is no alpha carbon. Okay, there is no alpha carbon. Here this type of compounds are participating Cannizaros reaction. So this is a participating Cannizaros reaction. So this is a not participating Cannizaros reactions. Okay. So next I can write one more example. So this is the benzaldehyde. This is the benzaldehyde. Okay. So alpha carbon must be sp3 hybridized. So this is the functional group. Okay, this is the functional group. Adjacent carbon is alpha carbon, but this carbon undergoes to sp2 hybridization. So that's why there is no alpha carbon. So there is no alpha carbon. It is also participating in aldol condensation. Okay, aldol condensation. So I can write one more example: CH3, CH2, C double bond O, H. So this is the functional group. This compound has, this is the functional group. Adjacent carbon is alpha. Then alpha hydrogen is also present. So that's why this compound cannot participate in aldol condensation. So this compound not participating in aldol condensation. So I can write one more example. So this is also participating in aldol condensation because of there is no alpha hydrogen. So a question everything are doing. So which compounds are not participating in aldol condensation? Okay, which compounds are participating in aldol condensation? So without alpha hydrogen compounds are participating. Without alpha hydrogen compounds are participating Cannizaros reactions. So with alpha hydrogen containing carbonyl compounds are participating aldol condensations. Okay, so aldol condensation discussed in previous session. So here we are discussing only Cannizaros reaction. Okay, Cannizaros reaction. So I can write. Okay, so reaction. So here this is the formaldehyde. Okay, this is the formaldehyde. So here without alpha hydrogen. So this is a formaldehyde without alpha hydrogen. Okay, without alpha hydrogen. So in presence of sodium hydroxide concentration, sodium hydroxide. So it converts to alcohol. Okay, alcohol and sodium salt of carboxylic acid. Sodium salt of carboxylic acids. Okay. So this is the Cannizaros reaction. So here 1 mole of formaldehyde undergoes to oxidized. So 1 mole of formaldehyde undergoes to reduced. Okay, 1 mole of formaldehyde undergoes to oxidized. 1 mole of formaldehyde undergoes to reduced. So generally we know that aldehyde count. Okay, aldehydes. So any aldehydes, so we can oxidize it, we get carboxylic acid. So this is the carboxylic acid. So in case carbonyl compound undergoes to reduction, we get alcohol. This is the alcohol. So here the products are this is the oxidized product. Okay, this is a reduced product. So here this is a reduced product. Okay, reduced product. Reduced product. So this is a oxidized product. Oxidized product. Oxidized product. So that means same element, okay, same element undergoes to both oxidation and reduction. So that's why it is the disproportionation reaction. So we know that disproportionation reaction. Disproportionation reaction means same element undergoes to both oxidation and reduction. Okay, so this is the reduced product, this is the oxidized product. So suppose this carbonyl compound gives two products. This is a formaldehyde. So what is the oxidation state of formaldehyde? What is the oxidation state of formaldehyde? So here carbon and hydrogen is there. So with respect to hydrogen, with respect to this hydrogen, carbon has more electronegative. That means this is a +1. So this is the -1. Okay, so with respect to this hydrogen, this is a, just wait. So here carbon and hydrogen, which is the more electronegative element? Carbon is the more electronegative when compared to the hydrogen. So that's why electron displacement towards the carbon. So carbon gets negative charge -1 with respect to hydrogen. So with respect to this hydrogen, this is a +1, this is a -1. So with respect to oxygen, among the carbon and oxygen, which is the more electronegative element? Oxygen is the more electronegative element. That's why electron displacement towards the oxygen. So oxygen valence is -2. So with respect to oxygen, carbon +2. So net +2, -1, -1, +2. So net is 0. So here 0 oxidation state is there. So then it gives two products. So one is the reduced product, another one is the oxidized product. So here this is a alcohol reduced product. So reduced product. So here what is the oxidation state with respect to hydrogen? Hydrogen is a +1, carbon is -1. So here hydrogen is +1, carbon is -1. See here hydrogen is +1, carbon is -1. Okay, here oxygen is a -2 with respect to hydrogen and +1. So then remaining part, this is the +1 of carbon. Here -2 is there. So -1 shared with carbon, -1 shared with oxygen. So that's why here -2 +1 gets hydrogen, here +1 gets carbon. So net oxidation state is okay, -3 + 1. So net oxidation state is -2. So here what is the oxidation state of this carbon? This is the 0. So here -2. So oxidation number is decreased, 0 to -2. Decreased means this is a reduction. So reduction product is alcohol. So whenever the aldehydes undergoes to reduction to produce alcohols produced. So here then this is the second product, acid. This is the second product of sodium salt of acid. So here with respect to hydrogen, this carbon has -1 oxidation state. This is a +1. So here oxygen is -2. Okay, so with respect to oxygen, this is the +2. Okay, +2. So here this is oxygen is -2. This is a +1. Remaining +1 shared with carbon. Okay, carbon. So here net oxidation state is -1 +1 get cancelled. We get net oxidation state is +2. So here oxidation state is 0. So here oxidation state is +2. That means oxidation number is increases. Oxidation number is increases. That means this is the oxidized product. And this is the oxidation process. This is the reduction process. So whenever the carbonyl compounds undergoes to reduced, the products are alcohols. So whenever the carbonyl compounds on oxidizes produces carboxylic acid. okay, carboxylic acid. So here this compound addition of hydrogen, how many number of hydrogen is there? So 1 and 2. So here how many number of hydrogens is there? 1, 2, 3. That means addition of hydrogen, that means reduction. So reduction means reduced product. So here how many number of oxygens is there? 1 oxygen. So here how many number of oxygens is there? 2 oxygens is there. So addition of oxygen nothing but oxidation. So this is the oxidized product. So in this concept we conclude this reaction is disproportionation reaction. That means same element undergoes to both oxidation and reduction. That's why this is a disproportionation reactions. Okay. So next we know that second conclusion. So this is the third order kinetic. Okay. This is the third order kinetic reactions. This is the third order kinetic reaction. So third order kinetic reaction. So in this reaction, so rate depends on, okay, rate. So rate is directly proportional to, okay, rate is directly proportional to concentration of reactant. That means aldehydes. Rate is directly proportional to concentration of aldehyde. Okay, how many number of aldehydes is there? 2 moles of aldehydes. HC double bond OH. So 2 moles of aldehyde, I can write power 2. Then also this reaction depends on the concentration of NaOH, that means nucleophile. So OH minus, so power 1. So therefore I can write rate equals to K concentration of formaldehyde. So concentration of formaldehyde and concentration of nucleophile. Okay, nucleophile. So here the rate of reactions, okay, the rate of reaction depends on initial concentration of the reactants as well as sodium hydroxide. That is this is the third kinetic order reaction. So here M plus N value is 2 plus 1, 3. So this is the third order kinetic reaction. So first one is, in these compounds, which compounds are participated? Without alpha hydrogen, carbonyl compounds are participate in Cannizaros reaction. Okay, next this is the disproportionation reaction. That means same element undergoes to both oxidation and reduction. So next point, then rate is directly proportional to initial concentration of the reactant as well as nucleophile. So that's why this is the third order kinetic. Okay, third order kinetic. So I can write mechanism. Okay, so I can write mechanism. Okay, so I can write mechanism. So I can write here mechanism. So first step, this is the sodium hydroxide. Okay, concentration sodium hydroxide. Okay, sodium hydroxide. So sodium hydroxide is the strong electrolyte. That means it completely dissociate into their respective ions. So మన sodium hydroxide తీసుకుంటే ఏమవుతుందంటే complete ఏమవుతుంది, dissociation అవుతుంది, Na plus and OH minus. Okay, then in second step, so I can take first mole of carbonyl compound. So here base OH minus, this OH minus is a base which can accept as a proton, which can accept the proton from where alpha carbon, but here alpha carbon is no alpha carbon. That's why OH minus act as a nucleophile. What is a nucleophile? Nucleophile means electron rich species are called nucleophiles. So here nucleophile OH minus means excess of electrons is there. That's why this is act as a nucleophile. So nucleophile attack on from where? Electron deficient species. So here electron deficient is where oxygen is a more electronegative element. That means electron displacement towards the oxygen. Oxygen gets partial negative charge. So carbon gets partial positive charge. So where the positive charge? Carbon has positive charge. So that's why nucleophile attack on here. Then electron displacement towards the oxygen. So we get new compound. We get HCO minus, then hydrogen, then OH. Okay, OH. So here, this is the neutral species, this is a charged species. So among the resonance, according to the resonance, which species is more stable? Neutral species is more stable than charged species. So that's why this is a rearranges. So I can write those step. So I can write those step. I can take another mole of formaldehyde. I can take another mole of formaldehyde. Okay, formaldehyde. So here this compound is taken here, O minus and OH, then H. Okay, so this is the charged species, this is the neutral species. So charged species is less stable when compared to the neutral species. So that's why these electron displacement towards here, this hydride ion H minus, so I can take hydride ion H minus displacement towards here. So because of this carbon has partial positive charge, this oxygen has partial negative charge. So this hydrogen displacement towards this here, so we get H so we get H. So then electron displacement towards oxygen. So oxygen gets negative charge. Oxygen gets negative charge. So this carbon has positive charge. That's why hydride ion H minus displacement towards the positive charge. So here H minus. Okay, H minus. Then we can get remaining part here. Hydrogen is there. Hydrogen then connected to carbon. So carbon here double bond is there. Electron displacement towards here. So oxygen connected through double bond to the carbon atom. Then carbon has OH minus. OH minus. So here this is a conjugate base. How it is conjugate base? We know that chemical equilibrium and ionic equilibrium. So suppose methanol CH3OH. So this is the alcohol. Alcohols are weak acids. Okay, alcohols are weak acids. So it converts to CH3. Acid means which provide the H plus ion, O minus and H plus. So this is the weak acid, conjugate base is a strong. This is a conjugate base. So strong base. Okay, strong one. So because of weak acid, conjugate base is strong. So that means this is a strong base. Okay, this is a strong base. Strong base. Base means can accept the proton. So here acid is there. Here acid is there. Acid means which provide the H plus ion, which releases the H plus ion. This H plus ion goes to here. So we get so this carbon, how many number of hydrogens? 3 hydrogens. 3 hydrogens. CH3. Then connected to oxygen. Oxygen connected to proton. Methyl alcohol. Then we get HC double bond O. So this oxygen loses the proton. Oxygen gets negative charge. So here sodium is there. This is the Na plus. So we get sodium salt of formic acid. Okay, sodium salt of formic acid. This is the Cannizaros reactions. So I can explain once again. So in this reaction, so which compounds are participating? So without alpha hydrogen carbonyl compounds are participated. So this is a without alpha hydrogen carbonyl compounds. So in this compound, one compound undergoes to oxidized. Oxidized product is sodium salt of acid. So one product is reduced product. Reduced product is alcohol. Okay. Same element undergoes to both oxidation and reduction. So that's why it is disproportionation reaction. A disproportionation reaction. So here first concentration NaOH is there. So this is a strong electrolyte. So strong electrolyte means the species which can completely dissociate into their respective ions in aqueous solution. So we get a OH minus. Then so I can take first mole of formaldehyde. So in this reaction OH minus act as a nucleophile because of it has negative charge. Okay, so nucleophile attack on electrophilic center. So here oxygen is a more electronegative element, electron displacement towards the oxygen. So here carbon positive charge, then nucleophile attack on, here we get this compound. This is the unstable compound. So because of this is a charged species, this is a neutral species. So that's why this compound rearranges. So again electron displacement to here, this hydride ion displacement. Hydride ion means H minus. So displacement towards the electrophilic center, electron displacement towards here. So we get this compound. This is the conjugate base of methanol. So methanol is a weak acid. Weak acid conjugate base is strong. So that's why which can accept the proton from bare acidic compound. So your acid is there. That's why which provide the H plus ion attack on oxygen. We get alcohol and sodium salt of carboxylic acid. Okay. So this is a basic information. So this is the third order kinetic reaction. So because of rate of reaction depends on initial concentration of the reactant as well as nucleophile. That's why this is the third order kinetic reactions. Okay. So here in this reaction, two species act as a nucleophile. One is a OH minus act as a nucleophile. So second one is the hydride ion. H minus shifted to here. So it is also act as a nucleophile. Hydride ion as well as OH minus act as a nucleophile in Cannizaros reaction. Then next exercise. So here the given the one compounds, here four options is there. Okay. So sodium hydroxide react with the concentration NaOD. So this is a isotope of hydrogen D. Deuterium is a isotope of hydrogen. So which product is obtained? So here, so first, so I can write NaOD. So this is a strong electrolyte. So that's why I completely dissociate into their respective ion Na plus and OD minus. OD minus. I can take first mole of formaldehyde. Okay, first mole of formaldehyde. So OD minus act as a nucleophile. So nucleophile attack on electrophilic center, then electron displacement towards the oxygen. So we get HCO minus, already one hydrogen is there. Okay, so next OD also is there. So this is a neutral species, this is a charged species. Which is the most stable? Neutral species is the most stable. That's why this species is rearranged. So I can take second mole of formaldehyde. Second mole of formaldehyde. Okay, second mole of formaldehyde. Then HCO minus OH. Next OD. So here electron displacement towards here. Again this hydride ion shifted to here. Again electron displacement towards here. So we get which? We get, just a minute. Just a minute.